The sensor manager and sensor provide functions to directly access various device sensors and acquire their values. The important functions of the sensor manager include functions to identify if a specified sensor is in the device, to attach the listener to the sensor, and to define the time interval for the device to notify the application of the sensor state through the listener. The acceleration sensor provides the function that returns how much acceleration is applied in the x, y, and z axes. The magnetic sensor function enables acquiring the direction of the magnetic field in micro-Tesla units in the x, y, and z axes. The proximity sensor function is used to detect when there is an object close to the surface of the phone, such as when the mobile phone surface makes contact with the user's face. The tilt sensor function returns the current orientation of the device, giving the azimuth, pitch, and roll values in degrees. Let's have a look at how we can register the listener and get data through the sensor manager. I created the listener object and created and constructed the sensor manager. Then, I tested the device to identify whether the acceleration sensor is supported by the device and, if it's available, attached the acceleration sensor. Here, the first parameter is the listener object, and the second is the sensor type. The third parameter, 50, indicates that the listener function should be called every 50 milliseconds to notify the state of the device. Finally, the parameter false defines whether to call the listener function every 50 milliseconds unconditionally, or only when the value retrieved from the device is different from the previous value. If this parameter is false, the listener function will be called unconditionally every 50 milliseconds. Otherwise, the listener function will only be called when the value of the device has changed. Then, I added the magnetic sensor. Now, let's see how we can implement the listener. The listener object is iSensorEventListener, and the listener function name is onDataReceived. Now let's look at this function closer. This function returns the sensor type of the data source. If the sensor type is acceleration, and there is a sensor data object to be retrieved, you can read the data by calling the getValue function of the object, passing the key with the required data. Here, the parameters are x, y, and z. Next is the weather sensor. The weather sensor does not refer to an actual device in the phone, but the weather forecast information for today or later provided by the server. This class provides weather forecast functions. You can get the data through the listener, just like the other sensors. You can get the current weather object corresponding to the current weather, and the weather forecast, which corresponds to the weather forecast through the listener. The current weather provides functions to get the current humidity, location, atmospheric pressure, temperature, and wind information. You can easily get a short phrase expressing the current weather, such as cloudy skies, foggy, and so on. The weather forecast class provides functions to get the highest, lowest temperatures, and weather conditions for a specified location at a specified time. Let's see how we can use the weather classes. First, the iWeatherEventListener listener object is created. This class has the weather sensor as a member variable. This class is constructed by passing it in the location value and constructing the weather sensor. If the requestCurrentWeather function of the weather sensor is called, with the location as the parameter, the onCurrentWeatherReceived function is called asynchronously. The onCurrentWeatherReceived function receives the parameter weather. This weather parameter contains information including the current location and the weather. The location is retrieved first, and then the temperature-related information, such as the current temperature, perceived temperature, and the dew point are retrieved. Then the location string is acquired and printed, as well as the temperature. The humidity is acquired using the getHumidity function, and the atmospheric pressure is acquired in millibar units using the getPressure function. You can specify the location with a string in the same way as the other weather services. Now, let me summarize UIX. The UIX namespace has been created to provide more advanced I/O mechanisms than the conventional I/O mechanism. You can detect and recognize faces from raster pictures, such as images or videos. And by using haptic, a physical feedback mechanism is implemented. The motion class abstracts and delivers complex inputs, such as the snap or shake movements to the application. Then we looked at the sensor manager. The sensor manager is used to directly access various sensors, such as the GPS, magnetic sensor, accelerometer, proximity sensor, and tilt sensor. And finally, the weather class provides functions to acquire weather information from the server.